Hello everyone, welcome to the course Digital Signal Processing. In the previous class, we studied about the overview of the digital signal processing. We studied about what are the concepts you are going to learn, that is we studied about the syllabus and what are the prerequisites, that is the textbook and reference books it is required to understand this digital signal processing we studied. In the today's topic, we are going to continue with where we have left in the yesterday's class. So in this, we are going to study about what is the necessity to do the conversion from analog to digital values and what are the steps are used in order to do the conversion of analog signals into digital valve signals will be studied. And after that, we go for the different transformation techniques what we are going to use in the digital processing mechanisms will be used. It may be Z transformation, it may be Laplace transformation, it may be Fourier series, and it may be Fourier transformation. And we are going to use in which are the fields these transformations plays an important role in the form of analysis of the signal. And later we studied about a Fourier series in details and what is the importance of Fourier series when we want to do the signal processing we'll be studying in this class. Okay, so now let us look into the analog to digital converters. So basically this analog to digital converters are nothing but it is a conversion of continuous wave signals into a discrete signal. You can see in the figure 1 we have a sinusoidal signal, and this sinusoidal signal has to be converted into a discrete manner. So if you want to convert this analog signal into digital values, we mainly go for a three important processing or three important steps in order to convert this analog signal into digital signals, and those steps are nothing but the first one we call it as a sampling. So when you want to do the sampling, that is when we want to do the continuous signal into discrete signal, one of the fundamental techniques what we are going to do is the sampling mechanism. So in the sampling mechanism, in order to satisfy or in order to perfectly reconstruct the given signal from the sampled value, we go for a Nyquist criteria. So if we sample the given signal with the use of the Nyquist criteria means, then we can perfectly reconstruct the original signal from the discrete value. So therefore, sampling techniques has to be used properly in the form of conversion of analog signals into samples and discrete values. And after doing the sampling, we go for the quantization. So because in the sampling there are several samples values has to be there, and these samples values has to be quantized or it has to be minimized. So in order to minimize these samples values or the discrete values, we go for the quantization. So this quantization is a second step in the conversion of analog values into digital values. And after doing the quantization, next we go for the coding. For the each quantized value, we go for an binary values we are going to assign them, and this assignment of binary values to the quantization levels we call it as a coding mechanism. So these are the one of the some of the techniques what we are going to use in the conversion of analog signals into digital signals. And one more important thing what you need to study is when we get an analog signals, we need to process it before we go for an actual analog to digital conversion. So for that we will be using a band limited signal, or we use a low pass filters in the incoming signal, and when we want to do the data transmission we will be using a band pass filter. So the frequency filters or the band of frequency what we are going to allow for our representation plays an important role in the frequency analysis of the any given signal. So in the form of digital signal processing, when you want to process the signal, you need to know account you need to play an important role in the frequency component, in which frequency component your signals lies about, because this digital signal processing plays an important role in the frequency component of the given signal, whereas the time domain approach. The next one is the transformations. So why we require these transformations? So we have studied about several transformation like Fourier transformation we have used, Z transformations we have used, Fourier Laplace transformation we have used, Fourier series, DCT series, and a Waverlet transformation we have used. So generally we are going to use this Fourier series in order to analysis or in order to represent the time domain signals into discrete frequency domain signal for the periodic signal, and we are going to use a Fourier transformation for the non-periodic signal. Similarly, we go for this Laplace transformation and also the Z transformation. And this DF, that is a discrete Fourier transformation, we are going to use in order to categorize the low frequency component into high frequency component. Means if you want to do the segregation of the component, frequency component value, means then we go for the discrete cosine transformation and also wavelet transformation. This discrete cosine transformation and wavelet transformation plays an important role in the speech and image processing applications. Now, what do you mean by transformation? So transformation is nothing but converting one form of signal into another form of signal. So why we need to do this transformation is that because we want to analyze some of the fundamental components or some of the parameters of the given signal in the natural form of representation of the given signal. So those parameter cannot be visible. So therefore, if you want to have a look on such a parameters, we need to use a transformation. So in order to understand why exactly this transformation is required, so this is the one of the image what I have kept it for your reference. So you can see here the real images what we have, that is the original image. So if I apply an Fourier transformation or some frequency transformation technique, so this is how it will look like over here. Now if the given signal it has been passed through and low pass filter, means then if I see the frequency component of those low pass signal, means so this is how it is concentrated, means the frequency values are concentrated over the center, whereas the remaining frequency components are distributed uniformly around the center point. Whereas the reciprocation of low pass filter, if the given same image, if it is passed through a high pass filter, so this is how it will look like. Whereas the frequency component, how it is, means the abrupt changes in the given sample values, so it is looking like in this manner. And one of the simple example you can see here, so if the bare hand, if it is scanned through, means so this is how you are going to get it. So if you have any defect or if you have any problem with the bone technique, means then if you want to understand where exactly wound has happened, means then we go for a scanning. So in the scanning we can able to identify if there is any bone fracture is happened or not through the use of this x-rays values. So this x-ray is also one of the examples of transformations. So in the normal view it is not possible for us to understand where exactly the damage has been happened in our inside of the bone system. So if you want to understand where exactly the defect is there, so we go for the x-ray. So x-ray is also one of the good example for transformations, or in order to know the in detail analysis of the parts of our human body. And you can see in the several fields we have used, we have applications of these transformations. So for example, in terms of doctors, so if they want to analyze the pulse rate of the human, then we go for a ECG signal, that is a echocardiography we are going to use. So where what we are going to use, the variations of the pulse rate with respect to spatial coordinations we are going to use. So means what, the given signal we are going to represent in terms of spatial coordinates, so that we can able to see the variations in the pulse rate of the human being. So this is how we are going to use the transformations in the form of in the medical field. And one more transformations where we can see is in the form of the musicians. So you can see here when we hear some that is a music. So basically music is nothing but the combination of different frequencies values. So some frequency values will be pleasant to for us and some frequency values will be unpleasant to hear the song. So basically this music is nothing but it is a combination of change in frequency values. So if you want to analyze some of the ragas, means then definitely you need to concentrate on which are the frequency values are situated for different ragas, so that we can come up with a better ragas or composition in the music field. And in terms of circuit voice, so in order to analyze the given signal, we have a different types of entities or different types of devices. For examples, we have a oscilloscope. So through the use of oscilloscope, it is possible for us to see what is the input signal we are applying, what is the output signal we are applying, and we have some function generators also. With the use of these function generators, we can able to generate any form of signal. So let's say I want to apply an 230 volts AC signal, means then through the use of the function generators, I can able to apply this 230 volts. Or if I want to analyze analysis the 230-volt signal means, then I can make use of these function generators. I can make sure that whether the input is appearing for my circuit or not, we can able to see. So these are some of the examples where we can make use of this transformation for the practical implementation.